afternoon, boys. So today we're doing higher order quadratic equations. So that means that we've got an equation where the highest power of x is more than x squared. So if you're looking at an equation with x cubed, x to the power of 4, x to the power of 5 as the highest power of x, that's what we're dealing with. They will be able to be reduced to a quadratic equation. You might be thinking, well, how's that possible all the time? But the ones that we give you in the textbook and in your exams will always be able to reduce down to a quadratic equation. So, the highest power of the letter, or the pronumeral, is called the degree of the equation, or the degree of the polynomial. You don't need to know this. This is an extension. I'm just teaching you these terms because you will be seeing them in year 11 and 12. So, in extension 1, you will be doing a whole topic called polynomials, and you will be using the word degree when you do that. We're not going to refer to it as a polynomial here because we don't really do them, but we will be calling it a degree sometimes when we refer to the degree of the equation. Okay, so how it works. Here's your hint. So we're always going to make sure that our equation is written in decreasing order of powers, starting with the highest power of x, or whatever the letter happens to be, and working our way down in decreasing order of powers. Then we look at the middle term. You are going to end up with 3 terms. You look at the middle term, and you ignore the coefficient, which is the number in front of that term. And whatever you're left with goes here. So we're going to let u equal whatever that thing is. Now, I'm only using u because that's what the textbook's using. You can call it any letter you like. We normally do anything that's sort of not being used generally, so it's not going to be an x because that's often in your equation, but u's okay. All right, sometimes people will use m or some other letter. Okay, so in all of these questions we're going to be solving the equation. So here's our first one. We've got y to the power of 4 minus 12y squared plus 32 equals 0. So I told you to make sure that it's in decreasing order of powers, and this one already is because we've got y to the 4 first, then we jump down to y squared and no y's at all. Okay, so now we're looking at the middle term out of the 3 terms. That's minus 12y squared. Ignore the coefficient of minus 12, and we're just looking at this bit. So that's what we're going to let u equal. So let u equal that thing, y squared. All right, and when we do that, at the moment, we've got a y squared there. We're going to replace it with the u. So wherever you see the y squared, you're going to replace it with u. Now over here, we have to find a way of writing y to the power of 4 using y squared. So this is what we're doing. Y to the power of 4 could be rewritten as y squared squared. Because you know the rule that when you've got an index inside and outside a bracket, they multiply. So if you multiply those, you will get y to the power of 4. So we're just rewriting y to the power of 4 as y squared squared. Now, if you look at the y squared and put a u in that spot, you've got u squared. Okay, so now we're looking at a quadratic equation. So I told you it would come down to a quadratic equation, but it's got a different letter. So we've got u squared minus 12u plus 32 equals 0. So we're going to factorise this left-hand side here. Just do what you normally do. The product is positive 32. The sum is minus 12. Go through your factor pairs for 32. We'll be dealing with 4 and 8 to get a 12. This tells you that the highest is going to get a negative, so the 8 will get the negative. And this tells you the signs are going to be the same, so the 4 will get a negative as well. Okay, so now we're dealing with u's, so we put our brackets down with u in them. Slide your minus 4 and minus 8 into the brackets. And then we're going to take each bracket and make it equal to 0. So we have u minus 4 equals 0 and u minus 8 equals 0. If you solve those two, you get u equals 4 and u equals 8. When you get to there, don't just stop and think you've finished the question. You haven't. They've asked you to solve an equation that had y in it. You can't tell them that the answer is u equals 4 and u equals 8. So we're going to get the u and put the y squared back in for u. Right, so instead of u, we're going to write y squared. Instead of u, we're going to write y squared. So now we have two more little equations to solve. Y squared equals 4 and y squared equals 8. So don't forget, if you've got a squared, we know that we're going to end up with two solutions. One being a plus and one being a minus. And we're going to go to the other side and square root. So we have plus or minus the square root of 4, which is plus or minus 2. Over here, we have y squared equals 8. Again, you know you're going to get two answers, plus or minus the square root of 8. Simplify your third, and it comes down to y equals plus or minus 2 root 2. So if we put all our answers together up here, we have y equals plus or minus 2 and plus or minus 2 root 2. So if you have a look, you've got four answers there. A positive 2, a negative 2, a positive 2 root 2, and a negative 2 root 2. Four answers. And if you look back at the original question, we had an equation of degree 4, or a polynomial of degree 4. Now, if an equation has degree 4, you will have, at most, 4 solutions. You'll have the same number as the degree at the most. You might have less than that. You might only have 3 solutions. You might have 2 solutions, you might have 1 solution, or you might have none. But at the most, it'll be 4 solutions. Now, I'm just extending you into a graphical application of what we're doing. This will be part of the Extension 1 course. If you go into doing the polynomials, it's quite easy once you get into it. All right, but basically, if we look at graphing this thing here, now you're looking at it going, well, how can you graph it when you've only got one letter there? But if we had x to the power of 4 minus 12x squared plus 32 and had a y in front of that, we could possibly have a graph that looks like what I've drawn on the board. That just moves up and down quite a lot. Now what happens there is it crosses the x-axis 4 times. So when we start solving the solution, we're actually finding the x-intercepts. So if you have 4 solutions up here, you're actually having 4 x-intercepts when we look at the graph. Okay, so I'll just adapt this graph slightly to what we're dealing with here, because we didn't have x's here, we had y's. So that would mean that would be a y down there, not an x. Okay, and up here, well, you can't call that y because that would be the same letter. You could call that anything else, okay, because we don't have one here. So call it whatever you like. Let's call it z. All right, so what I've actually graphed here is z equals y to the power of 4 minus 12y squared plus 32. Okay, so instead of actually, when we find our x-intercepts, we normally find y equals 0. Well, that's like putting, we don't have a y here but a z. It's like putting the 0 in there. When you write that down, obviously write that under the graph because I'm running out of room here. Okay, but that graph could be different. Okay, you could imagine drawing a graph that might have 3 x-intercepts, or 2 x-intercepts, or 1 x-intercept, or no x-intercepts. Okay, so it can adapt to the question. I won't go into it any more here. If you didn't understand what I was talking about down here, just copy it down. It doesn't matter for what we're doing. You do need to understand all of this to get to your answer. That's it. I'll go through some more examples on the next video.